The important questions from real number chapters as follows. We might get the questions, this type of questions like where we have to prove that any positive integer is of the form of 2m, 2m plus 1 or 2m plus 3, or this type of questions like prove that any number cube of any positive integer is of the form 9m, 9m plus 1, 9m plus 8 type of questions. And moreover that we can get questions to prove irrationality, where it's not that much important, but they might give you the combination of these type of questions. We will see this in the following videos as well, and logarithm related questions as well. Alright, so first we will move on to prove 9m and 9m plus 1 plus and 9m plus 8, where we need to prove that. Before jumping in to understand this, first we have to understand the Euclid algorithm, Euclid lemma. Now if you look closely here, we can use this lemma or the expression a is equal to bq plus r, where a is greater than or equal to b and b is greater than r is greater than or equal to 0. For example, if I consider a to be any number, we can start from 6 as well here. 6 is equal to 3, 2 is 6 plus 0. According to this form, in this form, I am mentioning any number 6, 7, 8, 9, 10, 11, 12, so on. If you take any number, you will end up having the remainders 1, 2, 0, 1, 2, 0, 0, 1, 2, likewise. So b, as you can see, that is 3, and r, we can take approximately 0, 1, 2 values. That's it. R cannot be equal to 3. We can take one example of division as well in order to understand it much better, but I think it's enough to understand. For example, if I consider b is equal to 7, a could be any number. A could be 7, a could be 8, 9, 10, 11, 12, 13, 14, 15, so on. But as you can see, the remainders that we are getting is always in between 0, 1, 2, 3, 4, 5, 6. That's it. In between 0 to 6 only. So this is what Euclid lemma is. So now if you follow this question here, right over here, prove that cube of any positive integer is of the form 9m, 9m plus 1 and 9m plus 8. Any positive integer. Here we are considering any positive integer. Alright, and 9m, 9m plus 1, 9m plus 8, if we relate this expression with a is equal to bq plus r, for example, if we relate it with this, a is equal to bq plus r, and moreover we know that a is greater than or equal to b is greater than r is greater than or equal to 0. We already know that r will take the values from 0 to 8 only, and a could be any number. B, if we relate it with the Euclid lemma here, b is nothing but equal to 9 from this respective question. And whenever you came across such questions, we can easily identify the b value. Now moving on, a is equal to 9m plus r, because I am going to write this statement in this form, where b is equal to 9, q is equal to, since it is a variable, I am considering m, that is r. R will take value, as you know, from this to this. Now what we have to do, we have to cube, as the question itself suggests us to take a cube. So what I am going to do here, I am cubing this equation 1 both sides. According to this formula, a is equal to bq plus r, a is equal to bq plus r, a cube, a plus b whole cube, that is a cube plus b cube plus 3a square b plus 3b square a. I am expanding the given expression here in this form. A here is 9m and b here is r. just relate every coefficient with this equation or the formula or the identity. Alright, so here we are having a cube, here also we are having a cube. So what I am going to do here is I am sending this r cube to the right hand side, just separating it so that I can substitute all the values of r here and bringing all these terms, rest of our terms, to the one side. For example, these terms, as you can see, this term, and this term, because each include 9, so I am bringing all this term together here. After bringing all these terms together, I am taking 9 common out of these all these 3 terms, so that we can have the question in this, we can have the solution in this format. 9m, 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 as we are having 9m, 9m and 9m in the each term, in the beginning term. So what I am going to do, I am taking, since this is cube, so there will be 3 9s here, 9 into 9 into 9, so I am taking 1 9 out of here, so I will be left with 2 9s here, 9 square. M cube is same, I am not disturbing anything to this. 9m whole square is there, so I am taking 1 9 outside, so 1 9 will be left. M square is same, so I am taking 9 here from this expression outside. I am left with 3r square m here. Alright, and then r cube is same. Now we can replace this entire expression by q here, as you can see, and then q is nothing but, I am writing the same expression, this expression right over here, that's it. Alright, so this is the expression. Let r is equal to, now what I have to do here, we have to substitute one by one each values of r in this expression. So first I am taking r is equal to 0 and substituting in the same equation, that is, in place of r we are writing 0 cube. 0 cube is nothing but 0 into 0 into 0, nothing will be left, so 0 will be the answer. So 9q is same, so basically 9q is nothing but 9m form only, since we want, it says that cube of any positive integer will always be in the form of 9m, 9m plus 1, 9m plus 8. So if we just concentrate on that only, we will get every values of r, because these are the possibilities. If we substitute r in place of if we substitute 0, 1, 2, 3, so on in place of r, we will get every number, any number in this form only, 9m, 9m plus 1 and 9m plus 8, as you can see. As you can see here as well, every number, 9m, 9m plus 1, 9m plus 8, 9m, so on. I will explain you one by one each. So if in place of r I am substituting 1 here, 1 cube is nothing but 1 only, 9m plus 1 form again. Now in place of r I am substituting 2, 2 cube is nothing but 2 into 2 into 2, 2 cube is nothing but 2 into 2 into 2, that is 8. So it is already in the form of 9m plus 8, we don't even have to do anything here. If I substitute r is equal to 3, 3 cube is nothing but 3 3s are 9, 9 3s are 27, 3 into 3 into 3, 27. We can take 9 common out of this. 27 can be written as 9 3s are, and then we are having this term as well, 9q. So I am taking 9 out of this, so I will be left with q plus 3 here. So again it is in the form of 9m, 9m. Now proceeding on, if I take r is equal to 4, 4 in place of r I am writing 4, 4 cube is nothing but 64, 64 can be split and rewritten in the form of 63 plus 1, so that we can take at least something common out of it, at least we can take 9 common out of this. So the only way that we can split this 64 in 63 plus 1, we can take 9 common out of these two terms. 9 into q, 9q, 9 7s are 63, plus 1 is same, 9m plus 1 form, m is equal to q plus 7 here. Again moving on to find r is equal to 5, 5 cube is nothing but 125, most of the students get confused in this part here. So what we have to do here, we have to divide 125 by 9. So if we divide 125 by 9, we will have the nearest number that comes in 9 table is 9 13s are, that is 117. 125 minus 117, because we have to split it in this format. So 117 plus 8 is nothing but 125. 117, if we take 117 9 common out of 117, we will left with 9 into q plus 13 plus 8, that is again 9m plus 8 form. Again we can take r is equal to 6 cube, that is 216. 216 is automatically divisible by 9, we can write 24, so on. We have to go for r is equal to 7 and 8 as well. So this is the end of the video. I hope that you will understand this concept. You can revise it, and you can go through this video again and again. So what I am going to do here at the end, I will bring this together each term. So I will write this here so that you can copy the entire answer by yourself. So we don't need this, right? So I'm just erasing everything so that you won't get confused much.